Number 12, find the length of the cardioid. R is equal to 1 minus cosine theta, where theta runs from 0 to 2 pi. So for this problem, we know we need to use the arc length formula, S, in terms of polar coordinates, where S is equal to the integral from alpha to beta of the square root of f of theta squared plus f prime of theta squared, where this right here, this is our f of theta. So what do we have here? F of theta is 1 minus cosine theta. F prime of theta is going to be, the derivative here is sine theta. So what's under the square root? We have 1 minus cosine theta squared plus sine of theta squared. And this ends up as 1 minus 2 cosine theta plus cosine squared theta plus sine squared theta. And this whole thing right here, this is of course equal to 1. So we have 1 plus 1 is 2 minus 2 cosine theta. And once again, not for the first time in this set of videos, I believe, we are going to use the identity that sine squared of t over 2 is equal to 1 minus cosine t divided by 2. So multiplying both sides of this by 4, 4 sine squared of t over 2 is equal to 1 minus cosine t over 2, all of that times 4, which is 2 minus 2 cosine. I guess here I started to use t instead of theta. So putting all of this together, we have 4 sine squared of theta over 2. So we know we want the square root of this. So the square root of this is the square root of this is the square root of this is the square root of this. Square root of 4 is 2. Square root of sine squared of theta over 2 is sine of theta over 2, because sine of theta over 2 is always going to be positive as theta runs from 0 to 2 pi. As theta runs from 0 to 2 pi, theta over 2 runs from 0 to pi. So we are just merely left with, I think I can probably squeeze it in down here, or maybe up here. We're left with the integral from 0 to 2 pi of 2 sine of theta over 2 d theta. You can do a very easy substitution there. U is equal to theta over 2 to make this work. I'll just go ... The final answer is 8.